Hi, everyone. Hope you are enjoying Developer Days. My name is Osvaldo Pacheco. I'm a technical marketing engineer working mainly with the Crosswork suite of products. And today we'll talk about a solution that's provided by one of the products in this suite, right? Its name is Crosswork Hierarchical Controller. And well, today we're going to divide our session in two main sections, right? In the first one, we are going to review the tool and we focus on the problems that it solves. And in the second part of the session, we will see mainly how this API ecosystem of the tool, with particular focus on an API endpoint that it was designed to provide capability to receive generic queries to the network model, right? With that information, hopefully you will see how easy it's to integrate the information generated by Crosswork Network Hierarchical Controller and integrate that information into your regular operation workflows, right? So with that, well, let's move on to the overview of the tool. And in order to do that, well, we need to start talking about a particular problem that we have on common data transport networks, right? And it's the way they grow. They all grow based as the union of different technologies, but not only technologies, but also different layers, different domains, and different vendors as well, right? And usually we have control of these individual domains, right? So we have a set of tools that allows us to configure services, that allows us to get performance information and troubleshooting in a particular domain, right? But things get more complicated when we talk about relationship between layers, right? So if we want to correlate information in the type of, well, if a problem identified in a single domain, but it's being caused for a configuration in a different one, right? Or maybe even worse, if we are trying to receive information that it's performance information that is being received from the optical domain that is affecting a service that is configured on the IP side. Well, that's if not impossible, it's very, very time consuming, right? So that's exactly the problem that HCO is trying to solve, right? How? Well, by the building of a unified network model, right? This network model is possible by acquiring information from the different individual domain controllers that we have in the network, right? So this information, once it is acquired from the domain controller or the element management system of a particular domain, it's normalized and it is understood in terms of how different domains working in the same layer are connected together, or how different layers in the network participate in the configuration of a service that is running on top of it. We are able to include all this information as a part of this network model, right? And once the network model is configured, we can have visualization of a service and the configuration of that service all the way from the service layer down to the fiber layer, right? Yeah, if we have information on how to locate the fibers in a topology map, we are able to provide up to that information. If not, we're able to provide information all the way from the service to the lowest optical layer in the model, right? With that, well, HCO can be and it's able to control the complete network, right? With this, this information can be visualized in this type of maps, right? The topology map where we can see information of this, how these layers are related to each other. But we are also able to provide this kind of view, right? The one that we are seeing in the center, where we can see here the configuration of an MPLS tunnel, right? And how it is configured through all the different layers in the network, not only at the IP layer, but also in the optical layer, right? So we're able to see how it traversed through a router path, but also how it traversed the transponders, the ROADMs, and even all the way down to the optical amplifiers, for example, right? Well, once we have reviewed this, how this model is built, we can review very, very quickly the architecture of the platform, right? So on the bottom side of our diagram, we can see the platform layer that is provided by the infrastructure platform that is called NextFusion, common to some other products in our portfolio. NextFusion provides infrastructure services to HCO. In this case, for example, well, the Kubernetes environment for the orchestration of these containerized microservices that are running on HCO. But also, it also provides single sign-on services, authentication services, encryption, high availability, geo-redundancy, and even storage as a service and a database as a service for HCO, right? On the top, we have basically the blocks that conform our hierarchical controller product, right? On the left-hand side, we can see the core block or the brain where our microservices are managed and controlled, right? But we also see these two layers. The first one is the adapters layer, right? So we said that this unified network model is made or built by querying particular information that is gotten from a particular domain controller, right? Either an IP domain controller or an optical domain controller. Well, it is the adapter, the piece of software that was developed to acquire that information, right? So the adapter knows how to talk to a specific domain controller, how to get the configuration, the inventory, the performance, and the services information. And it also knows how to talk to it in order to provision services, right? So once this information is acquired by the adapter, that information is passed through the persistor layer. The persistors are in charge of getting this information, normalize it, and understand how this new information needs to be inserted in the network model, right? Once the network model is built, well, it is stored in the database that is provided by NextFusion, and this information is read by our applications, right? So you can see here that we have a number of applications running as a part of HCO. Each application is able to read information from the network model and to attack a particular problem or a particular use case, right? Applications are independent from each other. They don't depend on the output of a different application to be able to work. However, if you're trying to solve a business problem, we can use one or more applications to get the required information to solve this business problem. This information is presented to the user via either the user interface or the north-down interface of HCO, right? If we zoom a bit from the control part, we can see that we also have an embedded NSO. Recent versions of the platform incorporates the use of an embedded NSO to attack particular use cases on the provisioning side, right? In particular, NSO is used to provide or to provision layer 2 and layer 3 VPN services, right? Services configured via the embedded NSO are discovered by the brain, right, and incorporated to the network model via the persistor layer that we already reviewed, right? So we can see here as well that brain uses the adapter layer. It's an example. We're communicating here our model with a couple of domain controllers, while NSO uses the nets for this type of communication, right? And with this overview of the platform, we can talk a bit about the applications, right? So, and we don't talk about individual applications, but sets of applications that are intended to attack different use cases, right? For example, in this case, we're talking about inventory and topology, right? We already talked a bit about this topology map over here. Its name is 3D, the 3D map. In this map, we were able to present information of the network in different layers, right? The IP only layer, optical layer, or both, communicated by the these inter connection links that we have, or the physical touch points between these two layers of the network. But we are also able to present this model that we already reviewed, where we can see the relationship upwards and downwards, a particular layer, all the way to showing the different relationship between layers, right? We are also able to provide a inventory information via a different application, where we can present multi-layer, multi-vendor inventory. This information is queried directly from the particular domain controller, so it is a very, very reliable source of information for inventory, right? We also have a path visualization, where we are able to present a service, a layer 2 or layer 3 VPN service, related to its transport traffic engineering policies. And with that information, we are able to also map the path of the traffic for that particular service through all the different layers in the model, right? In terms of risk management, well, with this information, we are able to solve or to answer this type of questions, right? For example, what's the impact of taking down a set of resources because of a maintenance window, for example, right? In order to answer these type of questions, we need to understand the physical risks in the network. So it is not only about the having information about a couple of services sharing the same line card, for example, in a particular either IP or optical equipment, but also we are able to provide information related to physical risks related to fibers sharing a particular location, for example, right? And we can use another application called layer relation to understand what is the relationship between different configurations at the network level, right? For example, what is the relationship with a set of traffic engineering policies to a particular lambda running on the DWDM side of the network, right? So this type of tasks can be accomplished via the risk management tools that we have, right? We can also work on the diversity assurance, right? So we are able to, we already talked a bit about it, we can define the policies where we are able to, for example, configure the tool to find fibers that even if they are transported in different ducts in the street, are close enough to share risk if something happened in this area of the city, for example, right? So we're able to find that type of violations to the policy that we are defining, right? We already talked a bit about root cause analysis. With this layer relation, we are able to find out how failures located in the IP world are related to the optical world, for example, right? How a failure detected on the IGP layer is related to a particular rodent degree, for example, a failure located in a rodent degree, right? So that type of information can be get right away from the root cause analysis tool. We talked a bit about performance again, right? So there are several places where we can obtain performance information depending on the use case that we are following. We can use the performance application. We can click on a particular link on the 3D model and get this type of traffic related to utilization. Or as Paola mentioned during a previous presentation, we can have this link assurance view where we have all the IP equipment and all the optical equipment in the middle, transporting this type of traffic related to that particular service, and where we can click on each of the layers of the model, obtaining different health information, right? Information related to that particular layer, for example, the traffic utilization, Ethernet OAM information, Q factor, frame error correction, and optical transmission and reception powers, depending on the layer we're clicking, right? And that can give us information on the health of that particular layer, that particular relationship between the two equipment, right? And last but not least, we have services creation applications, right? So we are able to provide information, for example, in the case of a run link, where we need to provision IP information and also optical transport information via the correct domain controller that we need to use, right? The IP information will be sent to the routers via the IP domain controllers, while the optical information is sent to the optical network, transponders, ROADMs, amplifiers, etc., via the optical domain controller, right? And well, with that overview of our platform, we can explore a bit about the API ecosystem, right? And these are the endpoints that we have. So the API of hierarchical controllers is very rich, right? But if we just see the name of the endpoints, and now with the knowledge that we have on how the network model is built, we can infer that these endpoints were developed to query a particular part of the network model, right? For example, the device manager application, API, was developed to query about, well, sites, how the network elements are related to those sites, location information, etc., right? While the inventory API endpoint, for example, allows us to query information regarding ports, line cards, power supplies, OS versions of the different network elements that we are managing, right? However, things get more interesting when we start combining information on different objects, different parts of the network model, right? For example, if I would like to know if a particular type of card is installed in a particular site, right, in a particular country, for example. So that's a more complex query, right? And that's where we can start getting out the complete information that we have in the model, right? And that can be done using these last endpoints in the list, the generic queries, right? However, and you can see here that this information could be extracted from the model by iterating many times in these different endpoints. Well, the idea of the generic queries endpoint is to try to simplify that query in a single statement, right? And in order to do that, well, we need to review particular language that was designed by Sedona, the original developer of the hierarchical controller, that is called Sedona Hierarchical Query Language, right? This language was designed to query the objects that we have in the model, that you can see the objects in the diagram and the different types of objects that are related to them with simple keywords, right? So we don't need to memorize complex queries to try to get out the information of the model, right? So we use simple keywords that allows us as well to transition from one object type to another one, right? So in the same query, we can query about, for example, SRLGs or links, and then use that information to place a next query on an object of a different type, right? For example, inventory or site. Let's see how it works. The SHQL information is available via not only the API, we also have an SHQL application that allows us to build the query, right? And once the query is built, it can be just copied and pasted in an API query tool, right? And we'll see that in a bit in Postman. But we can use this online help, right? If we don't remember exactly the name or of the object we want to query or how to place a condition, well, we can use this online query. It's available. And with that, well, we can start making the queries we want to do, right? For example, in this first case, I'm querying about all the inventory items. So I receive as a response all the inventory items in the model. In the next one, I can start filtering by adding conditions. In this type, I'm just querying about the type, the objects in the inventory item information with the type of equals to the router, right? Equal is not the only operand. We have different, we have greater than, lesser than, and includes, right, as operands. So we can start placing different queries with this language. So let's see how it works with a particular example, right? In this case, we know that there is an OSP down between Moscow and Bucharest, right? So we would like to know the root cause of this failure. There are several ways to attack this particular question. In this case, well, we can use the root cause analysis tool, for example. But let's see how it works if we start playing with the complete model of the network, right? So let's see first how to solve it using the UI, right? And we can go to the network inventory tool, and from that, click on the get the LSP information with LSPs with operational state down, and then filter for Moscow and Bucharest, right? The name of the sites that we are looking for. And once we have the name of the LSP, we can click on it, and the model will take us to the map where the affected resource is located, right? In this view, I can click on the path information, and there we will see the model. I mean, we have been talking about this layer relation between the different layers of that take place in the configuration of this particular MPLS tunnel. And we can see, if we query the lowest layer in the model, that is the OTS layer in this case, a fiber segment between amplifiers that has the problem, and we can see from there that that's the root cause of the problem you're receiving at the LSP level, right? If by clicking on that particular segment, we will be directed to the affected resource. This can be done easier and in a programmatic way via the API, right? So as you can see here, we can, if we want to take the same approach that we followed on the UI, first try to get the name of the LSP that is down by querying the link object for objects working in the LSP layer with an operational status of down, and from there filter for the Moscow and Bucharest endpoints, right? However, this could be done in a different way, right? So if we want to do it in a single query, we can look for the LSPs with I'm here using the specific name that I got from the previous query, but I can use, instead of the equal, the includes operator, where we can from here look for the endpoints that we are looking for, right? Moscow and Bucharest. Then use the exit of this query to be used as the input for the next one, that in this case is the downward function that will allow us to review all the layers that are below the affected layer we are looking for, and from there look for links with the operational status down, right? And from there we can see that we're getting the same type of information that we got from the UI in a programmatic way. So this way we can, for example, create a new ticket on an application like ServiceNow with the particular information of the LSP that is down and the root cause that we find via the network model, right? A different example, in this case, for example, well, we can take this example, you'll notice that is affecting a particular OTN card, but we would like to know where they installed and what are the top 10 affected sites, right? So in a simple query, we can get all that information by querying by particular part number on the object called inventory item, then grouping all that information that is gotten from the first query by the site name. We can use any other information in the model. In this case, I'm using the site name, order it in a descendant way, and limit our results to 10 results. So we get the top 10 affected sites where our line code is being used, right? And with that, well, hopefully you can see that, well, HCO provides a unified network model for the IP and the optical worlds. This information provides not only, relationship information between layers, but also visibility and provisioning capabilities for this type of services, all the way from the service layer to the fiber. And that all this information, this multi-layer, multi-domain, multi-vendor information, is available via a simple but powerful API. And well, thank you for attending, Omar. Back to you, Osvaldo.
So a couple of questions.
Sure.
One, multi-vendor seems to be pretty central to being able to do this, right? You know, as much as we'd love everyone to have just Cisco gear, that's not the case. So what kind of multi-vendor support do we have in HCO?
Oh, well, yeah, thank you, Omar. Well, it depends a lot on the domain, right? So the vendors are not the same for the IP world than for the optical world. We also need to find the specific information on the versions that we're using. But in the IP world, we work with, of course, with Cisco, main domain controllers, CNC, and EPNM. But we also work with Juniper Northstar, for example, and we also support information from Nokia IP domain controllers. In the optical side of the house, besides Cisco, where we support the ONC, the Optical Network Controller, and EPNM as the most used optical element manager for Cisco optical gear. We also work with Ciena, MCP, with Huawei, and with Nokia, for example, right? Something important information to add here is that, well, there is a procedure, right, that we need to follow in case we would like to have additional adapters supported, right? We can go through that in a next session. But yeah, there's a procedure that we need to follow with the business unit in order to have a new adapter developed, right? If it doesn't exist yet.
Yeah, I think that's an important point. So you guys, much like the NSO team, we take ownership of building adapters, maintaining them, make sure they're up to speed with the latest OS revisions from their vendors and those kinds of things. I think that's a key point in terms of making life simpler for customers. So HCO itself, what's the deployment model? How does this typically get implemented at customer locations?
It's very important to mention this, Omar. The deployment model for HCO is very simple, right? So it's a single VM deployment model. It is based on a single VM. Of course, well, the VM includes all the applications and the different blocks required for it to work. The only components that need to be installed, let's say, in a separate way are the adapters, right? So adapters are licensed and, of course, installed on a case-by-case basis, depending on the different domain controllers that we have in the network. And because of this high availability and geo-redundancy capabilities that we have in the tool, we can also deploy it in a cluster way, right? So we can do local high availability or geo-redundant high availability fashion, and we will need to install these individual VMs in different locations, right? But the deployment model is very simple. We just need to accomplish with the compute resources that we need in terms of the deployment. These latest versions of HCO runs on top of VMware, but it's a single VM deployment, right? So that's very easy to deploy.
Cool. So do you think, I mean, do you find with the customers deploy HCO, it replaces other things? I mean, in general, does this allow them to simplify their automation stack, or is this just another thing that's layered on top of what what they have already that starts to knit things together?
The intent of the tool is not to replace existing element managers, right? So the idea is actually not to talk directly to the network elements, but to query the information, get the information from the actual existing domain controller or element manager, and use it to perform or to build this network model, right? So it adds information, right? It adds a new visibility layer, and well, it can become the single point of control for the network instead of replacing individual tools, right?
Sounds good. Thanks, Evaldo. Appreciate the session.